Welcome to the TechMind Factory video blog. In this video, quick overview of software delivery with GitHub Enterprise. We are going to talk about features available on GitHub platform that will help you with managing your software supply chain. We are going to talk about managing source code on GitHub, creating different branches, how to apply branch protection rules, and also how to deploy the code to different kinds of environments. So let's start. Here it is, GitHub portal. I'm already authenticated, and as you can see, for my organization, GitHub Enterprise trial is enabled. My current organization is Predica, as you can see. And before we move forward, it's very important to understand the structure of organizations available on GitHub. So on GitHub platform, there is a concept of organization. You can create many organizations and you can assign licenses to them. And within organization, you can create different source code repositories and different teams that will be responsible for managing those source code repositories. So in this case, I have Predica organization created. And as you can see, within Predica organization, I have different kinds of source code repositories. So different projects in this case. So if I scroll up and I will click my profile icon, you can see that there is this tab called Your Organizations. So currently I'm assigned to Predica organization and I can see all the repositories within this specific organization. So here, before we move forward, it's very important that I can invite people to my organization. So on the right side here, there is this button called Invite Someone. So you can invite people available on GitHub and they will join your organization. And then you can decide to which team you would like to assign those people and to which source code repositories. So by default, all those source code repositories are visible to organization members. So there is like a read-only mode enabled. And here, as you can see at the top, there are different tabs: overview, repositories, packages, people, teams, projects, insights, and settings. So let's start with Teams tab here. So under Teams tab, I can create different teams within my organization that will be responsible for managing different source code repositories. And of course, I can create infrastructure team that will be responsible for managing source code repository where infrastructure code is stored, but I can create also application development team that will be responsible for developing web application. So I can create many different teams and then I can assign them to specific source code repositories. So as you can see here, I can click Create New Team. And of course, I can provide details, description, and also what is worth to mention that we can assign the parent team. So within your organization, you can create different teams, but you can also create a hierarchy here. So there will be one general team, and under this team, you will have smaller teams assigned. So it's very important to mention that. And of course, there is team visibility. So teams can see each other within organization, but of course you can change this from visible to secret, and then there will be like a secret team within your organization. But here I already created Cloud Predicants team. So if I click this one, you can see that on the left side there are two members within this team. So it's me and my colleague from organization. And here there is this discussion tab. So this is the place where we can start discussing different topics within this specific team. Yeah? So it can be really helpful because if I'm in the application development team, I can start discussion, and maybe this discussion is important for my team, but there are some other teams focused on something else, so there is no communication mismatch. And of course, as I mentioned, if I switch to Members tab, here we can see the members of this specific team. I can click Add Member button. So if I will do it, I can search by name here, and I can invite people to this specific team. Then, if I switch to teams, as I mentioned, here we can create the structure of teams. So there can be general team, and under this general team there can be smaller teams assigned. And under repositories tab here, I can add repository to this specific team. So let's see how to do it. If I click add repository button here, I can search a repository within my organization, search by name, and I can add this repository to the team here. So if I will try to type something, there is a search bar and there will be a list of repositories displayed. But I've already added one of those repositories, so Cloud Predicants. And as you can see, I can set a permission level to this specific repository for this specific team. So of course, there are different kinds of options. This specific Cloud Predicants team is administrator team, yeah. So they have full access to the source code repository. They can apply changes and they can do everything what they want. But of course, we can also set read level here for other teams. So we can make this source code visible to other teams, but they will not be able to modify anything. And this will be really helpful in the future if you want to have like a transparency among teams within your organization on GitHub. So even if there is someone from the infrastructure team, maybe this person would like to see what is happening in the web application source code because there is some issue. So this can be really helpful here. So we can assign different permission levels for specific teams when it comes to access to different kinds of repositories. So here I have this Cloud Predicants repository assigned to this specific team, so Cloud Predicants. And also what I can do here, I can assign projects. So we will talk about projects later during this video, but I just want you to know that if you would like to manage work or tasks that are assigned to specific people, you can do it using projects on GitHub, but later we will talk about it. And there is also a settings tab. There are some additional settings, but now we will specifically focus on the repository section. So if I open Cloud Predicants repository here, we can see that there is a source code of my web application, demo web application I would like to show you today in this video. But before we move forward, it's very important that here in this specific repository, there is also a section called projects. So if I open projects section, there is a new project created, Cloud Predicants. I can click new project button. I can provide the name of this project. I can also select the template. So I can use basic Kanban, automated Kanban, back triage. So there are templates to be selected. And if I select one of those templates and I click create project, then such Kanban board is displayed. And this is somehow similar to the Kanban and Azure DevOps boards that is available in Azure DevOps tool. And we will talk a little bit about differences in the end of this video. But I would like you to understand that this is like a quick way of planning different tasks with different statuses. So in this case, as you can see, I have this really simple Kanban board with 3 columns: to do, in progress, and done. And here I can add different cards. Yeah. So in this case, I have this implement data caching, implement communication with web service. Those are to do. In progress, there is one task, prepare design for the main page, and implementation of the user authentication is already done. So here, if I click edit this node, you can see that I can edit description. Of course, I can also add more cards here, and I can also add more columns if I want. Yeah? So in this case, it's really possible. And here again, if I want to add another node, I can add this node, click add button, and then it will be added, and there will be information that this was added by this specific user in the organization. And of course, it's not so extended yet when it comes to projects. But in the future, what is on the horizon, there will be GitHub Issues functionality extended, which I would like to just really briefly describe now. During recording this video, this functionality is in beta, so you have to sign up and you will be put on the waiting list, and you can then explore this new issues functionality. But if I scroll down, let me show you something really quickly. There will be a possibility to switch between table and board. So this is the new look and feel of GitHub issues. So here I can have this board, as I showed you in the project section. In the future, this will be in the issues, and I can switch to tables here. And I can have different phases planned in my project, so prototype, beta, launch, etc. And this will be really helpful when it comes to planning and managing different statuses and assignments. So as I mentioned during recording this video, it's in beta right now. You can submit using this button here, but it's very important to mention that in the future, GitHub will be extended with this great functionality for GitHub issues. So if you are currently using Azure DevOps boards, probably this will be something what you would like to look at in the nearest future. So let's get back to GitHub again. Great, so we discussed project section, so let me right now get back to the code section. And here, if I extend branches, you can see that currently I have two branches, main and develop. So of course here I can create new branches, so we can either find an existing branch or we can create new branch. So it's like a standard functionality of Git version control. But if I will go to the settings tab here and I will select branches, this is a more interesting section. Because here, of course, I can set default branch in my source code repository, but also I can enable branch protection rules. And this is really important. So it's obvious that we don't want to push changes directly to the main branch or develop branch. Of course, it depends which branching strategy we have. It can be Git flow, GitHub flow, whatever. But still, there will be branches where we don't want to push the source code directly, so push the changes directly. So in this case, as you can see, I have main branch and develop branch. And now, if I click Add Rule, I can provide the branch name pattern. So in this case, just the name of the branch. And I can apply different protection rules. So I can require pull request reviews before merging. So with this feature enabled, everyone who would like to add anything new to the source code base will have to create pull request. And someone will have to review it. We can require status checks to pass before merging. So here we can apply pre-build validation, for instance, or execute unit tests to make sure that everything is good and there is no regression. We can require conversation resolution before merging, and there are some other protection rules. As you can see, we can create such protection rule. And I already did it for two branches, so I have main and develop branch protection rules. So let's see what's happening in the protection rules for develop branch. So as you can see here, it's created for the develop branch, so we can see that it applies to one branch. I require pull request reviews before merging here, and at least one reviewer from the organization has to review those changes and either approve or reject. Also, I have this rule for status checks to pass before merging. And here I would like to check whether my application is building properly before merging those changes. And also I require conversation resolution before merging. So if there will be any comments left by the reviewer, I will have to read them. I will have to explicitly mark them as read, and I will have to respond in this case. So once I applied those protection rules, I can click Save Changes. And right now, let me show you what will happen in the Visual Studio, and let me present a sample web application which source code is stored here in this Cloud Predicants repository. So let me switch to the Visual Studio now. So here it is. This is my Cloud Predicants web application. It's Blazor web application. It's simple demo application that is hosted in the Azure cloud. So it's worth to mention that here I have two environments, development environment and production environment. So once the code is merged with develop branch, then there is deployment done to the development environment. And once the code is merged from develop branch to the main branch, then there is a deployment to the production environment. We will talk about environments and releases in a minute in this video, but I would like you to understand what is happening when it comes to the branching protection rules. So here is the web application. Let me switch to the Visual Studio. Here is the source code of this project open in the Visual Studio. And if I will switch to the Git changes, you can see here that I have this new feature branch created called change logo. So in this case, I just want to change the logo of this application that will be displayed on the main page. So here I can provide description. So in this case, I will just enter a message, update logo on the main page. And I will commit it, and then I will push this branch to GitHub. Once I pushed this specific branch to GitHub, we can see that there is information that there is a new feature branch, and maybe we would like to compare changes and create pull requests. So if I click this button here, what I can do here, I can say that, okay, so I want to merge those changes to the develop branch first. And here I can create a pull request to make sure that someone will review those changes. So let's see what's happening here. I will create a pull request. And here, if I scroll down, we can see that branch protection rules are applied. So first of all, someone from the organization has to review my changes. That's the first thing. The second thing, we can see, of course, that merging is blocked because of those branching protection rules. So there is one more thing required. The build validation has to pass here. Yeah? So the build has to be successful, and once build validation is successful, then we can merge changes. So in this case, we can see that here build validation was successful. So everything is fine. We didn't break anything when we applied the changes. We can see that there are no unresolved conversations. So if there will be code review done by someone else from my organization, from my team, if there will be comments left, there will be information on GitHub that you will have to first resolve those comments, answer those comments, close those comments before you can merge changes. And at least one reviewer approval is required in this case. So to make sure that I will make it faster, I will just describe the process, but here I will accept this pull request because I'm an administrator in this project. So what will happen here is what will happen on the other side. Someone from the team in my organization, in my team, will receive email notification that there is a code review required and new pull request was created in this case. So we can decide on GitHub whether we want to inform different team members about this fact, or we can explicitly here select the person who will be a reviewer for this specific pull request. Yeah? So this person can be automatically assigned by GitHub using round robin algorithm, for instance, or we can just explicitly say that, okay, in this case, I would like to indicate my friend who is responsible for verifying those changes. So here, if I select a specific person, she or he will be notified and he or she has to review those changes. And once those changes are verified, everything is fine, we can merge this pull request. In this case, I will accept this pull request as an administrator. In this case, to make it faster, I can confirm merge. And right now, what will happen, right now, the source code will be built from the develop branch, and the package of web application will be deployed to the production environment. So if I switch to the Actions tab here, we can see that in this case, there is a new deployment is being done to the development environment. So first of all, the package with the application will be built. So the source code will be built. Once the package is ready, it will be deployed to the development environment. And here, let's stop for a minute. So I switch to Actions tab. So let's talk about GitHub Actions and about environments in this specific case, because I want you to understand what is happening when it comes to managing releases to different kinds of environments on GitHub. So if you used Azure DevOps before, Azure DevOps tool for managing builds and releases, I'm sure that you are familiar with Azure DevOps pipelines. So you can define pipelines in the YAML files. What will happen, for instance, when you push the code to the develop branch, the package with the application will be built, and then a unit test will be triggered, and then, for instance, you will release this specific package to specific environment, let's say to Azure environment. So here, in the Azure cloud, I created two Azure web applications with the web application I showed you before. So this is my development environment and development resource group where application is located. And also I have another resource group where my production environment is located. And now if I select, let's say, this development environment application that is deployed, let me click browse really quickly. And after a few seconds, we can see that the previous version of the application is displayed. So this is the old logo that we updated in the feature branch. And we would like to merge those changes to push those changes to the development environment. So here, to do it, we will need GitHub Actions. So with GitHub Actions, we can define many different kinds of tasks that will be triggered once we merge something to the specific branch. So it is exactly the same like in the Azure DevOps pipelines. We can decide that we would like to build specific kind of application. So let's say that this is .NET application, so there is a specific task responsible for building this application. Then we would like to release this application to the Azure cloud, to the Azure web app. So there is another task responsible for doing this job. So there is another action, I would say. Yeah? So in this case, there are many different kinds of actions. Let me show you. This is the marketplace with different kinds of GitHub Actions. And as you can see, those different kinds of GitHub Actions are not only for .NET applications or web applications. There are many different kinds of actions that we can use with different kinds of applications, frameworks, and tools. So in this case, if we, for instance, want to deploy something to Azure Cloud, I can type Azure, and you can see that there are GitHub Actions that will provide, that will help me to deploy to Azure Cloud, for instance. So in this case, as you can see here, there is this Azure Web App GitHub Action. And with this GitHub Action, we can deploy web apps, containerized web applications to Azure. And also, as you can see, there are different actions, like for Azure Functions, for instance, if you would like to deploy Azure Functions, Azure PostgreSQL action, and many, many more. So as I mentioned, those GitHub Actions are available in the GitHub Marketplace. Those actions are developed and provided from the commercial companies, but also from the community around GitHub. So in this case, you can use some of them for free. So it's really helpful in this case. So now let me get back to GitHub. This is again GitHub Actions section within my source code repository, and we can see that this action, this action is waiting for something, and there is this information that it's waiting for the review. So dev needs approval to start deploying changes. So now let me explain the concept of environments on GitHub. If I will switch to the Settings tab here, and I will select Environments, in this section, we can define different kinds of environments. And you can think about environment like, for instance, development environment, test environment, production environment. So in this case, this is like a separated sandbox where you can define protection rules again. Like, for instance, you can decide that before something is deployed to the production environment, someone has to approve it. But also you can separate secrets that are used within a specific GitHub action when deploying to specific environment. So here when I click New Environment button, I can define the name of the new environment. So I already created production environment and dev environment. And here, if I select dev environment, in this case, you can see that, first of all, before deploying anything to the dev environment, it has to be approved by someone. And we can add up to 5 more reviewers. So in total, we can have 6 approvers in this case. So to make it simple, in this video, I added myself, but in the real world scenario, this can be like, for instance, project manager in your organization responsible for this specific project. We can also set a wait timer here, so set amount of time to wait before allowing deployments to proceed. And also below, we can see that we can assign deployment branches. So this can be used to limit what branches can deploy to this environment using branch name patterns. So if we get back to the source code repository structure, as you remember, I created 2 branches. Develop and main. And right now I'm saying that deployment to development environment will be done using develop branch from my source code repository. So in this case, the package with web application will be built using source code from the develop branch, and then this package will be pushed to the Azure cloud, to the development environment using GitHub Actions. And the same is for the main branch. I will show you that in a minute. But there is also one more important aspect, environment secrets. So in this case, as you can see, I have a published profile uploaded as a secret to this specific environment. It is used by GitHub Action to access my web application in Azure Cloud and to make sure that I can push new files and deploy my application. And in this case, this secret can be used only with this development environment. So again, we can separate secrets here. And of course, there are additional integrations. So if you would like to keep secrets in the Azure Key Vault, for instance, you can also do it. So if I get back to Environments tab again, and I will open Production Environment, you can see that still there is one reviewer required. So again, it's me to make it faster. And this specific environment is related to main branch. So to clarify, we can deploy to production environment only from the main branch. So we can deploy the packages built from the source code that is available in main branch in our source code repository on GitHub. And again, as you can see here under environment secrets, I have published profile for my Azure Web App that in this case, this is Azure Web App available on the production environment in the Azure cloud. So great. So this is about environments. So right now, in this case, if I will get back to the actions section here, and I will open this GitHub action, we can see that there is information that me, so Daniel K, is requested to review to deploy to dev environment. And of course, it's me in this case to make it faster. But in the real world scenario, as I mentioned, this can be like a project or product manager of this project. And this person will be notified with email, and there will be information that that approval is required before any changes are pushed to the specific environment. So here I can click review deployments, and as we can see, I can select that, okay, so in this specific case, we would like to deploy this web application to the dev environment. I can leave some comments, but I don't have to, and I can click approve and deploy. Or if we think that there is something wrong, we can of course reject this deployment. But in this case, I will click approve and deploy. And after a few seconds, we can see that this GitHub action for a development environment deployment is triggered. And after a few seconds here, there will be log displayed, as you can see right now. So we are getting the source code of our application, we are building the package, and the last step is responsible for deploying our web application to the Azure cloud. So if we will wait just a few seconds, we can refresh our web application in the Azure cloud to make sure that the logo was successfully updated. So let's do it right now. So we can see that this job is complete right now. So deployment was done successfully. So again, if I will open this one, we can see that deployment to dev environment was successful. And also we can see that in this case, deployment to the production environment was not executed successfully because the deployment was rejected or didn't satisfy other protection rules. So branch develop is not allowed to deploy to prod due to environment protection rules. So this is again related to environments I showed you just a minute before. So in this case, we cannot deploy anything to production environment from the develop branch. So now let's get back to the Azure portal and let's open our web application and let's see if the logo was updated successfully. So great, we can see that right now Cloud Predicants logo was updated. Perfect. So right now, let me get back to GitHub once again and let me describe GitHub Actions just a little bit. So this is the source code repository with the source code of the web application I showed you, but also under .github/workflows folder, we can see two YAML files. And those YAML files contain definition of the GitHub actions that I described a minute ago in this video. So if we want to build package with our application, or we can, I don't know, download NuGet packages, or we can connect to some external repository, or if we want to deploy to Azure cloud. In this case, we have to define those steps in the YAML file, in the YAML file that will be located under GitHub/workflows folder. So first of all, let's see pre-merge build validation, GitHub action. So as you can see, the structure is really similar to the structure of Azure DevOps pipelines and YAML files. So here in this case, first of all, we can declare that this GitHub action will be triggered on pull request that was created with requested changes from the feature branch to the develop branch. So it will be triggered when we want to merge something to the develop branch. Then we can declare environment variables, in this case, like path to the web app package or .NET version. And also under jobs, we can decide, first of all, the operating system of the machine where this GitHub action will be executed. So in this case is Ubuntu, so Linux. And then there are some steps. So in this case, we just checking out the source code. Yeah. Then in this case, we can build the package with the application. We can provide some additional commands like to restore NuGet packages to build our application package and publish it in this case. So, of course, in this case, we can decide from which branch we would like to check out the source code. But in general, this is like a basic idea behind the GitHub action. And the second, and the same is for the build and deploy. So let me show you really quickly what's happening here. In this case, as you can see, we can decide when this build and deploy GitHub action will be triggered. So in this case, it will be triggered every time there is new push of changes done to the main branch and develop branch. And again, we have some environment variables. So the name of the web application on the development environment, on the production environment, and under jobs section, again, we can decide which operating system will be used on the machine where a GitHub action is executed. So in this case, Ubuntu, Linux. And we can specify environment. So in this case, as you can see, for this first job, I'm saying that this job will be executed for the dev environment. So in this case, what's happening? Here, of course, I can check out the source code. I can build the application package, but then, as you can see here, what I'm doing, I'm publishing this specific package with application to the Azure cloud where my development environment is located. So in this case, development version of my web application. And again, if we scroll down, there is another job, but in this case, the environment is set to prod. So in this case, this job will be triggered only when we want to deploy something to the production environment from the main branch. And again, we checking out the code, we building the package, but in this case, we can see that we are publishing the package to the production version of our Azure web app, so to the production environment. And again, here we are referencing secrets, so publish profile in this case, and you can see that here I'm referencing the production version of the secret, and for the development environment, I'm referencing development environment. So in this case, there is this separation of secrets I mentioned before. And this is basically it. When we push those changes to the source code repository, those GitHub actions are automatically discovered by GitHub. And here, for instance, we can see that in this case, this is action responsible for building web application. Another action is for building and deploying web application to different environments. So as you can see here, we can see that application was built successfully. Perfect. So this is about GitHub Actions really quickly and what can be done. So there is also one more important thing I would like to discuss. So security in the software supply chain. So in this case, on GitHub, we can enable some additional security verifications. So if I will switch to the settings tab, to the security tab, here, what I can do, I can enable security advisories and dependable alerts. So in this case, let me briefly describe those functionalities. In this case, when I'm working currently on the source code and I'm using different packages, those different packages can have vulnerabilities discovered. And probably once this vulnerability is discovered, there will be new version of the package available. So it's really hard to track every new package of the open source library we are using currently in our project. So in this case, it's good to have security advisories and dependable alerts activated, because in this case, we can display information about, first of all, packages, open source packages that are used in our project, what are the vulnerabilities discovered, and also with Dependabot, we can create automatic pull requests that will have updated version of the specific library that we are using. So in this case, let me switch to other project that I have on GitHub to show you more about GitHub security features. This is my another project available on GitHub. And let me show you security features using this specific project because I created this specifically to show those features. So first of all, what is really cool when it comes to GitHub, we have this Insights tab. And if we open Insights tab and click Dependency Graph, we can see all detected packages, so open source libraries that are currently used in our project. So as you can see, there is OData package, Serilog package, and .NET package, so CoreFX. So in this case, first of all, we know what is happening in our project when it comes to usage of the open source libraries. This is really cool feature. If we switch to the security tab, as I mentioned, there are also security advisories and dependable alerts features enabled. So in this case, what will happen once there is vulnerability discovered, we will be informed about security advisories. So under security advisories tab here, there will be information that there is something wrong with specific library, there is vulnerability found, and we have to update this specific library to the newer version. But there is another great feature available on GitHub. So let me get back to the security tab. It's called code scanning alerts. So in this case, once we enable code scanning alerts here, we can see alerts. We can use something what is called code QL available on GitHub. We can enable scanning with code QL, and this will use GitHub Actions and code QL to scan our source code and detect not only packages with vulnerabilities, but also we can detect issues with our code and also issues with the licenses if we use any kind of external tools like Snyk. So in this case, let me show you first of all what happened when I scanned this specific project with code QL. And as I mentioned, to enable code QL here, we can enable code scanning using this security tab. I've already enabled code scanning. For new repositories, we can do it from this tab. So it's available for all public repositories on GitHub. But when we have GitHub Enterprise, we have to request this feature because it's available only when we have GitHub Advanced Security enabled for our organization. So that is why I'm showing you right now this using open source project. So when I switch to the code scanning alerts, first of all, we can see that here I scanned my code using a Snyk tool. So it's like external tool, commercial tool available outside of GitHub. And I can integrate with this tool using GitHub Actions. So again, here I can find a specific GitHub action in the GitHub Action Marketplace and integrate it to use this third-party tool, in this case Snyk. So as you can see here, we can see information that there is medium severity. Apache 2.0 license was used in the package that was discovered, and this package, this module, is called Serilog. And this is true because I'm using Serilog library in this project, which uses Apache license. Of course, here we can adjust the severity level for different kinds of licenses. I'm just showing you that this is possible, so you can scan your source code repository, you can check what's happening in your source code, you can see the dependencies, what open source libraries are used, whether they have any vulnerabilities, or maybe you use some packages with risky licensing model. So it's really important to verify it. And of course, when you enable code scanning with code QL, which is available on GitHub here natively, once the code QL scanning is applied, we can check different errors, or I would say not recommended patterns in our source code. So here is one of the alerts that was displayed after code scanning with code QL on GitHub, and we can see that in the source code there was try catch block found, And here in the catch block, we are catching null reference exception for the connection string. And if we scroll down here, we can see that there is show more section, and there are some recommendations for us. So instead of using try catch block as it is done right now, we can use if else blocks. So we can check whether a connection string is null. If it is not null, we can proceed. If it's null, we can just display some information, or we can log this fact. So it's really helpful here. And again, this CodeQL scanning is available using GitHub Actions again. So in this case, if I go to the source code repository and I will open GitHub/workflows folder, here you can see that I have this YAML file called CodeQL analysis. And if I will open this file, you can see here that I'm using CodeQL to scan this source code repository. So here I can check out the source code repository, then initialize the CodeQL, and then I can build the project and perform CodeQL analysis. And CodeQL analysis can be applied to different kinds of languages. In this case, it's C#, but of course you can use it for any other languages like Java or JavaScript. So it's really powerful. Also, we can define different suites when it comes to the CodeQL scanning. So let me show you. In the CodeQL folder here, I have CodeQL config file, and here we can define which queries will be executed, because there are many different kinds of queries that can be used with CodeQL. So in this case, I apply security and quality queries to make sure that vulnerabilities in my code will be detected, but also there will be some recommendations like this one with the try catch block I showed you. This was just a brief overview of security features available on GitHub, but I really encourage you to watch my Pluralsight course called DevOps with GitHub and Azure, Implementing Software Supply Chain Security with GitHub, to learn more about GitHub security features in details. To summarize this video, I would like to talk a little bit about GitHub licensing. So of course there is like a free license available for individuals and organizations. But if you think about using GitHub in your organization or within your team, you should think about either team license or enterprise license. So the team license is for advanced collaboration for individuals and organizations. So it contains access to those features that I show you, like protected branches, code owners, required reviewers. And if you are big organization and you are on the enterprise level, you should probably think about enterprise license. So it includes everything what is included in the team license, but also there are some enterprise level features like advanced auditing, SAML single sign-on, or token and secret and code scanning features. So in this case, it's like extended package with all different kinds of features available on GitHub. And the last thing that I would like to talk a little bit about is integration between GitHub and Azure DevOps. So there are two primary supported scenarios when you still use Azure DevOps, but probably you would like to try GitHub. So first of all, you can use Azure DevOps boards with GitHub. So you can host your source code on GitHub, you can have pull requests on GitHub, but you can use Azure boards in Azure DevOps. So in this case, there is a connection between GitHub and Azure DevOps. So in the GitHub, when you create pull request, you can reference work items from the Azure DevOps boards. So of course, as I mentioned, the connection has to be established, and then you have access to the work items from your backlog inside GitHub. And the second scenario is when you want to still deploy to different kinds of environments using Azure DevOps pipelines. So in this case, there is also integration possibility between GitHub and Azure DevOps. So in this case, you can host your code on GitHub, you can create pull requests on GitHub, but builds and releases will be triggered in Azure DevOps. So this is another kind of integration that is possible. Of course, it has to be established, But once GitHub and Azure DevOps are connected, you can, after closing pull request, for instance, you can trigger build in Azure DevOps, and then you can release to specific environment using Azure DevOps pipelines. Thank you so much for watching this video. I hope you found it interesting and helpful. If you will have any questions, do not hesitate to use comment sections to ask them. Thank you once again.